Okay, so this is surface area, lesson 3. The first video we looked at the surface area of a rectangular prism and surface area of a cylinder, some basic review from grade 8. Now we are looking at the composite shapes. So, reminder, rectangular prism, cylinder. Okay, so now it says determine the surface area of the two prisms. So I'm actually going to pause the video here. I would like you to use your skills from the first the first example to find the surface area of each. I will put my answers up, but I'm not going to walk it through step by step like I did the first one. Okay, through the magic of Smartboard, these are solved. Amazing math. Okay, so when you look at example A, the first one on the left, we have the front side times 2, the left side times 2, and the top times 2. And so because these are all rectangles, area is just base times height, base times height, base times height. And so we times them, and then we add, and anyways, for shape A, you get an area of 220 centimeters squared. When we look at B, I hope you noticed for B that one of the measurements said meters, but the rest are all centimeters, so I changed it to centimeters. And so again, we have the front times 2, the left side times 2, and the top times 2. So if we scroll down a little bit, you'll see part B and the calculation. And again, all rectangles, so base times height, base times height, base times height. And we finish all of our multiplying before we add, and you get a surface area of 424 centimeters squared. And so the reason why we did all of that work is so that we could answer the second one. And so in the second part it says, rectangular prism A is stacked on top of rectangular prism B. And we want to know what is the surface area of the composite shape. That is, what is the surface area of the two prisms together. So we want surface area A plus surface area B. Okay, that seems easy enough. So 220 centimeters squared plus 424 centimeters squared. Ha! So we get 644 centimeters squared. Miss, give me something harder, you say. But wait. It is not that easy, my friends. I hope you noticed that A and B are touching along this face under here. So there is the rectangular bottom of A under there. And A is covering up part of A, and A is also covering up part of B. And so the part that is being covered up, if we scroll up to A, is this red face, okay, the top. So we said the top and the bottom. So this is actually the area that's being covered up. So it is no longer part of the surface area. It's part of the internal, it's now become part of the internal shape. So it's no longer an external surface. So we need to actually deduct that or remove that from the surface area. And we've lost this on A. But A is also covering up part of B. And the part that it is covering is the same size that is covered up for part A. So we're actually losing that same shape twice. And so the easiest way to do that is to go take our total area, and we're going to take away 2 of that base, and that was 4 centimeters by 5 centimeters. Again, keeping in mind order of operations, 4 times 5 is 20. 20 times 2 gives us 40 centimeters squared. So the actual composite area is 604 centimeters squared because some of the area was lost in the overlap. Okay, so this last example I'm going to leave you with. It's been a long 2 videos. This one's a little bit shorter. And so what I want you to do is I want you to think about, if these were the Linky cubes, I want you to think about what is the surface area that is shown. And I want you to think, okay, well, they're centimeter cubes. That means this length is 1 centimeter and this length is 1 centimeter, and they're all exactly the same. They all have lengths of 1 centimeter. So I want you to think about if there were 8 cubes, so this is 8 cubes. 1, 2, 3, 4, 5, 6, 7, 8. So this has 8 cubes. What is the surface area that you can see? And we're actually going to check this over in class, and we're actually going to complete part B together in class as part of an activity. So this is the end of video 4. If you are having any troubles at all with basic surface area, please see me. We'll take a step back and we'll do a little bit more practice on surface area before we move into composite shapes.